Hi everyone, this is Shrees and welcome to Code with Shrees. In this tutorial, we're going to be going over coding Go Lambdas that interact with Amazon Bedrock using the AWS Go SDK. Amazon Bedrock is a new and exciting tool that allows us to build generative AI apps similar to OpenAI's ChatGPT using what they call foundational models. So this is going to be a very beginner-friendly tutorial. So if you're excited to build generative AI apps, then let's get to it. We'll be starting in the management console to just get a basic understanding of Amazon Bedrock, as well as complete the majority of the task for this tutorial. We'll only be using the command line when necessary. So let's start off by navigating to the Amazon Bedrock service. Also note that I'm currently in the US East 2 region. Amazon Bedrock is limited to only a few regions at this time, but hopefully over time they will make it available to more regions. So the first thing we'll do is we'll request access to a foundational model. So over here under the model access page, you'll see a list of all of the foundational models that you have access to. So when we say foundational model, we basically mean that it's a model we can use to build other kinds of apps. Most of these models, I believe, are generative AI models. So that means that it can generate text and/or images. So in my experience, the Claude model is a really great model for generating text. However, it is limited access, as you can see here. So I will just be using the Drastic 2 model in this tutorial. So to request access, we'll then press Manage Model Access, and then click on the model we want. Scroll to the bottom and click Request Model Access. And today we can see that our request was granted very quickly, thankfully, but sometimes it can take a few minutes. So once access has been granted to the model that you want to try out, you can start playing around with it directly in the AWS console. So if you navigate to Playgrounds and then either chat, text, or image, you'll be able to use a ChatGPT/Midjourney-like environment to generate text and images. So I'll just click chat here. And then we need to select the model we want to use. So I'll press select model, and we'll see that the AI2 Labs Drastic 2 is already selected. And I'll just double click here to just make sure that I've also selected the throughput, and then click apply. So here we have the chat playground, which is very much like ChatGPT. So we can ask questions and have a conversation, just like with ChatGPT. So you see, I started off with a question about outer space, and this model was very fast, and it gave me exactly 3 succinct answers to my question, which is exactly what I wanted. If you're not satisfied with the default behavior of the model, you can use these settings here to modify the behavior to what suits your liking. So the text playground is a little bit different from the chat playground, as the name would apply, but it starts out the same. We select model, we select the model that we want, and click apply. And then here, there's not really a chat box like UI. Instead, you just write a prompt. So maybe we'll say, wow, that's really interesting. So it even gave me a title this time, which is very cool. So and it's very fast. So this is a great model to use. And unlike the chat version, there's no back and forth. It's just you type in a prompt and it gives you text back. And the playground, unlike ChatGPT, does not save your answer. So if you refresh the page, it will actually disappear. So with that, let's first start off by building our AWS Lambda execution role in the IAM service. Okay, so we're here in the Identity and Access Management Service, also known as IAM, and we're going to be creating a role, so we'll click Roles. Next, we'll click Create Role. And because this role will be used by a Lambda, then we'll need to use the AWS service option and then click Lambda down here. And it says commonly used, Lambda, and yes, Lambda here. Then scroll down and press Next. And next we'll need to add some key permissions. So the first one is the basic execution role for Lambda roles, which is required for all Lambda roles. And you'll see if you type in basic and then execution role, then the manage role will come up here. You'll see it's AWS managed, so click on this one. And the other role that we need is also the Amazon Bedrock role. So we'll type in Amazon Bedrock. And this will just give us full read and write access to Amazon Bedrock services. And then click Next. Okay, and our role name, I guess we'll just call it like Go Lambda role. And yeah, this allows functions to call AWS services on your behalf. We'll scroll down and we'll double check our trusted entities. So trusted entities just means what are the services or roles that can assume this role. So the Lambda service can assume this role, which is what we want. And if you scroll down to our permissions, we have added the Amazon Bedrock full access permission as well as the AWS Lambda basic execution role. So that is all we need here. And we'll just skip the rest and click Create Role. All right, and our role is now created. So next we'll navigate to the Lambda console. We'll click Lambda. And we'll click Create Function. We will be authoring this Lambda from scratch. And I guess we'll type in a function name. And our runtime, so this is like the language we'll be using, is going to be Go, but specifically we're going to be using the Amazon Linux 2023 Lambda, which supports the latest Go versions as well as Rust and C++. We'll click this. And we'll keep the architecture at x86 by 64. And we'll just use our existing role that we just created. Use an existing role, Go Lambda role. Scroll down, create function. So by default, Lambdas run for only 3 seconds, but generative AI models can take some time to run. Typically not too much time, but definitely more than 3 seconds often. So we do need to make sure that this Lambda can run for more than 3 seconds. And we're gonna update that by going to the configuration and then scroll down to this general configuration section, click edit, and then scroll down to the timeout section. And then we'll just set this to 1 minute. 1 and 0. And everything else will keep the same, and we'll press save. That we'll be building will take a prompt as an input and then call the Amazon Bedrock service and then return the result of that generation to the user. So the first thing we will need is to create the main.go file. And to limit the CLI use, we're just gonna create it with the UI here. So you can either right click and press new file, or you can just click one of these icons, this first icon. And we'll call it main.go. We will also need a Go mod file, and this I will use a CLI for. So we're gonna do a Go mod call here. Okay, and now we'll just start filling in our main.go file. So the package will be main. And I will just skip some of the imports here because I do have the Go extension, which will automatically import the requirements for us as we code. Our Go program will have 3 functions versus the main function. The next is a function just to handle requests in general. The handle request function will take a Go context, a Lambda event, and it will return a Lambda response or an error. And the third function will call Amazon Bedrock. So our function has a few red squiggly lines here, and we'll sort that out immediately. So Visual Studio has actually sorted out one for me by just importing the context, which is a standard Go package. But we also have this custom event called Lambda event, as well as a custom Lambda response, and that will be a custom type that we'll define up above. So this is kind of giving us a hint about what our function will be doing. So it will be taking a Lambda event that has a prompt and then outputting the Amazon Bedrock generation that was created. So now let's just quickly fill out the main function. Okay, and we can see here that Visual Studio Code has automatically imported the Lambda package, and we're just using this to handle whatever requests come to the Lambda. Next, we'll fill out the handle request function. Okay, so in our handle request function, what we're doing is first we're checking to make sure that we have a non-nil or non-empty event. And if we don't have a nil event, then we'll move on to running Amazon Bedrock. And Amazon Bedrock will give us a generative AI response, which I just called generation. And if no errors occurred in the Amazon Bedrock function, then we'll finally return the Lambda response. Now let's move on to the run Bedrock function. So in this function, we will be, of course, running Amazon Bedrock. And it will just take a string, which is the prompt. And if everything is successful, it will return the generated response. And if there is an error, it will also return an error. Okay, so before I start explaining what's going on in this function, I'm just going to create the custom types needed to get rid of some of these squiggly lines here. And we'll do that at the very top. Okay, so the first 2 new types that we created are these request and response types. So this is the request that the Amazon Bedrock client takes, and then this is the response that it will return. So it will take a prompt, the max number of tokens, and the temperature, and then it will return a text completion. Now this completion is also a custom type which we'll be creating now as well. So that's why it's still red here. So the last types that we added were basically just for this completion type. And the reason why we are being so detailed here is because in order to access the data in the generated text that Amazon Bedrock gives us, we need to use something called marshalling. So marshalling allows us to convert plain JSON into like Go types like this, which makes it much easier to use. And you'll see an example of that below. So we'll see that we're getting the response and then we're doing dot completions, 0, data, text. And the reason why we're able to do that is because we created those custom data types. And really quickly, I just saw we have an error here. So let me just go back and fix this. So yes, our request, I guess, is missing the max tokens field. Request max, oh yes, max tokens, like this, with an S. And everything looks good. So because I have the Go extension, pretty much all of these imports were already imported for me. But in case you don't have the Go extension, you can just go ahead and type those in now. And once you're done, we'll just go and run go mod tidy to import all of those into our package. Okay, and everything is downloaded now. And one extra thing I forgot, we also need to just quickly go over what this run Bedrock function is doing exactly. So all Lambda functions have this AWS_region environment variable set. So we're able to get the region from that variable. And then once we are done that, we need to load a default config. And because Amazon Bedrock uses Go routines, we do need to use context.background instead of context.todo. And we're also letting the config know that we're working in the same region that the Lambda is in. And then, yeah, we're just checking for errors. And then here we're finally getting the Bedrock runtime. So the Bedrock runtime is the package you'll need to what they call invoke the model. So that's basically just running the model. And we just load the configuration into that to make sure that our Bedrock runtime is in the right region and, you know, has everything that it needs. And then next we need to formulate our payload that we'll be passing to the invoke model method. So in this case, we have a prompt, max number of tokens, and temperature. And next we are using the marshal method to take this Go object or type and then turn it into a regular JSON object that is an array of bytes, what are called bytes. Then we're just going to check for errors again. And if there's none, we finally invoke the model. So this is the same as basically running the model. And to be clean, we just are using the invoke model input type here. So we'll pass a body. So the body is basically just the specific parameters needed for the model. And the structure of this body will be different depending on which model you're using. So we're using the AI21 Drastic 2 Mid. So this happens to require a prompt, max tokens, and temperature. But if you're using Meta or Claude or something else, it will be a bit different. So that's why you just have this one body parameter and then it just takes a bytes that can be shaped in any way. And then we just have some basic HTTP information here just to let it know that we're actually passing JSON that's just in bytes. And once again, we check for errors. And lastly, we of course, if everything is successful, we get an actual response. However, we can't really use that in Go unless we unmarshal it. So what we do is we take that output and we're going to get the response body and unmarshal it into this response object that we created. And once again, we check for errors, and if there are no errors, then we can finally return the generated text to the user. So this will basically return back up to the handle request function, and we're going to get the generated text here, and after that, we will just return back the generation to the user. So this kind of explains the basic use case for these models, so I think this is a really good example. But now, in order to run the Lambda, we do need to use the command line to compile the Go binary and then upload it to Lambda. So we have already downloaded our package dependencies using Go mod tidy. So the next thing we need to do is we need to run Go build with the correct architectures. So we're using the same command that we used in the other tutorial. So we have the Go operating system, which is Linux, and it's going to be 8664 architecture. So we need to specify that because different Lambdas have different architectures. So you need to make sure that this is set. And and the output file also needs to be called bootstrap. So these are all really important settings, and we'll just run this. Okay, and you can see that our bootstrap file is created here. Next, we need to zip the bootstrap file, which we can use as a Lambda deployment package. So now we have our Go Lambda zip here that we can use. So now let's head back to the AWS Lambda console to upload our Go Lambda deployment package. Okay, so we're back in the AWS console here in Lambda. Specifically, we're at Lambda functions, and then I clicked on the Lambda function to get here. And we'll go back to the code tab, make sure that code is selected, and then we're gonna click upload from, and we're gonna do zip file. And press upload. And then just look for the file in your computer and then click save. Okay, so once you've found and selected your deployment package, you can press save. Okay, so our deployment package was successfully used to update the Lambda function, as you can see here. So we can't actually see the code here, which is a bit different, but this is just standard for developing Go Lambdas. So the next thing we'll do is test the Lambda by clicking test. And we'll just call this event AI test. And the structure that the Lambda will be expecting is just to have a JSON object with just one field, which is the prompt field. And then here we can just create our prompt. So let's think and... Okay, so we're gonna try out sales here, and we'll just click save and then click test. And you can see that the Lambda was successfully invoked. We'll click details to see what it came up with. So it said, get the latest iPhone now. With all of its new features, this phone is sure to impress. From its powerful camera to its sleek design, the iPhone is the perfect choice for anyone. Don't wait any longer. Order, oh, slight typo. Order yours today. Okay, so this is pretty good. It was very fast. This time it actually didn't go past the 3 seconds, which is great, but sometimes it does. So just be mindful of that. Yeah, so that completes our tutorial. I hope this was very fun and you'll be able to use this for many other models. And I'll link key AWS documentation below so you can kind of learn about the different models, because each one does take different inputs. So you'll need to be familiar with every individual model to build different kinds of AI applications.